All right, so welcome back. This is part 2 of this video. So if you're looking for the full video, maybe go back and see part 1 if you haven't yet. But in this part of the video, I'm going to talk about this HMBC, which is a multiple bond correlation. I will also talk about a proton-nitrogen HSQC, which is just another interesting two-dimensional NMR. So just to catch up with where we're at, we have this chemical structure, and we're going to be asked to assign all of the different peaks. In the previous video, I used a COSY NMR and a HMQC to make these assignments so far. So I've got my carbon NMR, chemical shifts. I've got my proton NMR chemical shifts, and I've made some assignments so far based off of the COSY and the HMQC. And now for the HMBC, this is a little bit more complicated. So the HMBC is a multiple bond correlation. So the way that this is going to work, if we bring this back in here. So for instance, from this proton here, it's going to be a multiple bond correlation between a proton and a carbon. So this would be 1 bond, 2 bonds, 3 bonds. So this proton here, we should see a correlation with this carbon, number 8. I would also see 1 bond, 2 bond, 3 bond, a correlation with this proton here, or excuse me, with this carbon here. So from HF to carbon number 6, and then from HF, 1 bond, 2 bond, 3 bond to carbon number 4. So HF to carbon number 4. So let's sort of break it down. The first thing that I would do when I start analyzing my HMBC is label the peaks that I already sort of know about. The peaks that I already know, what their assignments are. So on my proton, axis, so this is my proton NMR, we know that that is F, we know that this is A, we know that this is D, this is E, and this is C. So that would be the first thing that I would do, because then when I start looking at that, that's going to make it easier for me to sort of figure out. On here, we can probably just use this little picture here. This is F, E, D, and C, and this is obviously A. So we can use that. For our carbons, what we already know at this point in time is that, so we know number 7, so this is 7. We know, what would be the next two? We would know that 9 and 10, so 9's on top of 10 right here, 125, 126. We know that this one is 8 at 134. And then we know that way down here at 190 that this is number 1. You guys probably can't see that right now. There we go. So that's what we know for our carbons. So we can start using that to make the other assignments, and also just to sort of confirm the information that we have so far. But without having some sort of starting point, it makes analyzing this HMBC much more difficult. On here, I'm also going to label my carbons. So 1, 2, 3, and then we came over here. Let's make sure that we label everything the same way. 4, 5, 6, 7, 8, 9, and 10. So I've got my carbons labeled, I've got my hydrogens labeled, and so now we can start going through this correlation process essentially. So for the first one, I guess, that we'll sort of start talking about, I would look at this peak C. So this is my proton peak for C, and I should see correlations with things that are 3 bonds away, and they should be very strong correlations. The strongest correlations that we're going to see, things like this, those are going to be 3 bond correlations. The weaker looking correlations, like this one here or this one here, those are going to be 2 bond correlations. So, when we're talking about bond correlations, so for this C proton, this would be 1 bond to get to 7, and I'm not going to see a correlation with 7. So there shouldn't be 1 bond correlations. We might see one as an artifact a little bit later on, but in general, if this is my line for C, this proton C, then I should not see any correlation with 7. I might see a weak correlation with 8, a weak correlation with 6, or I might not see anything at all. But I should definitely see a strong correlation, a 3-bond correlation with 9, and I should see a strong correlation with 5. So 1, 2, 3. So this C peak should correlate strongly with 9, 1, 2, 3. So C peak strongly with 9, that's what we're seeing right here. And then I should also see a strong correlation with 5. So this would be 1 bond, 2 bonds, 3 bonds. So this peak right here, that's telling me that this is probably carbon number 5. So right away, we can start filling in more information. So I'll put in brackets the new information that we're solving for. But that strong correlation with 5, I think that's pretty clear. Now, we also said that we could have 2 bond correlations. We could have, a correlation with 8. We could have a correlation with 6. And down here, I do see another correlation. So that could be a 1-2 bond correlation with 6. So this could be 6. It looks sort of strong, but there's no other, carbons that are 3 bonds away. So this could be 6. I think it could also be 8 at this point in time, although this would be 8, so it's definitely not 8. So this is probably 6. We can probably fill that in as the other correlation to this carbon, to this proton here. So proton C, 1-2 bonds away. There could be another correlation there. We're not seeing this correlation here for 8. Could be a variety of reasons for that, but I think that's okay. We just want to make sure that the things we are seeing, we can make sense of. E looks a little bit complicated, so I might skip over that one at first and just use that to sort of confirm things a little bit later on. Let's look at D next, since it's the next proton over here. So from D, again, we're going to count 1, 2, 3 bonds. So D should definitely have a correlation with this proton we've labeled 6, which it does. So D going down, I've got a correlation with 6. I've also got a correlation with, looks like 10. So D, 1, 2, 3, I should see a strong correlation there. And this peak here, that correlates with 10. It does look like it's a little bit below these other peaks. So these 2 peaks actually look below this peak here. So that would be correlating with 10. 9 and 10 are really close together here. But I would say that would be my 1, 2, 3 bond correlation, D to 10. So that looks good. No new information, just sort of confirming or reiterating some information. Let's jump over here to F, because F's got 3 nice peaks that are sort of easier to follow. So if this is my F peak, I would count 1, 2, 3 in this direction first. So F should correlate strongly with proton at 8, and that's what we see here. F to 8, 1, 2, 3 bonds away. And then on the other side, 1, 2, 3 to 6. So F to 6, we see that. And then also 1, 2, 3, F to 4. So down here, this F proton should correlate to strongly with the things that are 3 bonds away. 1, 2, 3, that's this carbon. 1, 2, 3, that's this carbon. 1, 2, 3, that's this carbon. So that's telling me that this is probably carbon number 4. So that's a good piece of new information. I think that it also does make sense. The chemical shift fits nicely. So this, carbonyl carbon, it should be, further downfield. And so we know that 1 is way down here, right? So we'd expect that 4 to be further downfield as well. So we've got a nice peak there. This peak right here, I think this is just an artifact. It doesn't correlate really well with anything. There's no carbon here. There's no real proton here. So I would just ignore that. That's fine to do. Let's go back and talk about E now, see if we can make sense of that. We're getting quite a few correlations here, which is great though. So for E, now I've got 1, 2, 3. E should correlate strongly with 5. So E to 5, that's this peak here. That looks good. E should correlate strongly with 1, 2, 3 with 7. So E to 7. So our 2 main peaks for E, the 2 strongest signals we're seeing there are 3 bond correlations. 1, 2, 3, which is 5. 1, 2, 3, which is 7. Those look good. And then I'm seeing sort of weaker correlations with some other stuff. So 1, 2, E to 10, that would be this one. So 2 bond correlation, that's totally fine. 1, 2, E to 8, that's this correlation here, totally fine. Now here, I've got a very light correlation between E and 6, which would be 1, 2, 3, 4 bonds away, but that does happen sometimes in these aromatic systems. So this is definitely within the realm of reason that we would see a very small signal there, which is 1, 2, 3, 4 bonds away, but our strongest signal should be 3 bonds away. But we do see that there, and that looks good for E. So everything is making sense at this point in time. In the previous video, I sort of said, you might have get to a point where something's not making sense, and then we'd have to go back and switch, which one of these was C and F. But this seems like everything's sort of working and making sense, so I think we're in good shape. We haven't talked about A, but A should have some correlations as well. And the first thing that I notice is these 2 peaks here. So what this is this is actually a 1 bond correlation, and then it actually splits the peak. So we know that this should be 1, and we know that this obviously is our signal, proton signal for A. So this correlation that we're seeing here, the fact that it's a 1 bond correlation is making it split, so we would have a coupling constant here. And so if we do see a 1 bond correlation, we should expect to see 2 peaks that are split, that are centered around, whatever this shift is for A. Now up here, we've got a 1-2 bond correlation with some other proton that we haven't labeled yet. So I would guess that that's going to be our proton here at 2. I guess it could be, what else could it be? It's not 4, right? So that would be 4. 1, 2, 3. It could be 3. So we don't have a correlation with 3 yet. So this could be 2 or 3. Now, since this number 3 is correlated to is bonded to nitrogen, I would expect that to be this proton here. So we'll call that 3. And then this one, we'll call this one 2. So I see this A is also correlated to this proton here, number 3, 1, 2, 3 bonds away. So I think that fits there. And then because this carbon's bonded to nitrogen, then I would say that it's probably going to be more in this 100 range as number 3. And then here, so number 3 here, and then here, number 2, that's going to be this proton here, which we've got another correlation, maybe a little bit stronger than we might like to see, but definitely within the realm of reason. So that's how we're going to analyze our HMBC. And now we're pretty much done, right? We've got most of the labels in. We can go ahead and start filling in our, our diagram from before. So starting at the bottom, I've got 3. So I'll fill them out, and then I'll show everyone sort of where we're at with our assignments. But this should be all of our 1, 2, 3, 4, all the way to 10, all of our assignments for our carbon NMRs. We obviously talked about our assignments for our proton NMRs already. So 167 is 2, and then 176 is 4. And then for our proton NMR, we already labeled, so I guess I can show you this now. So this is how I'm organizing all the information. I've got all of my carbon-13 peaks, all of my proton peaks, organizing everything together. So at 10.2, that's going to be A. And now our B peaks, if we go all the way back, so for those of you who are just tuning in for the HMBC, earlier we talked about this as our proton NMR, and I have 2 peaks for my NH2 group. So that's curious, and the reason that I've drawn my structure this way is because we're going to have a hydrogen bonding interaction that's going to shift one of these, the chemical shifts of one of these downfield. So this B prime is going to be this 9.9, and then B double prime is going to be the 5.8. So this interaction here, that's going to make these 2 protons, in different environments, and that's going to shift this proton pretty far downfield. So that's what we see here and here. The only last thing that we would talk about, which is pretty neat and sort of confirms what we just said, is this proton to nitrogen HSQC. So what this is doing is correlating the nitrogen signal to the proton signal. So we've got 2 correlations here. So 1 nitrogen center, 1 nitrogen atom in our compound, and it's correlating to both this peak here at 5.8 and this peak at 9.9, just confirming what we just said about our 2 protons here. So that's it, right? So we have completed this analysis. We've looked at our HMBC, we've looked at our COSY, we've looked at our HMQC in the previous video. And hopefully all that makes sense. I think that it's daunting at first, but going through it, especially with this HMBC, it's really helpful to have some information before you jump into the HMBC, and then take that information and sort of say, does this match up? Does this confirm? Remember, that's a multiple bond correlation, and the 3 bond correlation is going to be the strongest correlation. So for instance, if we're looking at E, this would be 1 bond, 2 bonds, 3 bonds. So E proton to 7 carbon, that should be a strong correlation we see here. E proton to 7 carbon, strong correlation. All right, hope that helps, and let me know if you've got any other questions or other videos. Cheers.